Here we're going to look at some AP problems that involve combining everything that we've talked about together in terms of the first derivative and the second derivative with increasing and decreasing, max and min, and concavity and points of inflection. So here we have a graph of f prime, and it tells us that this is the derivative of f. So it's really important to note that what we're looking at is the derivative graph. Okay, they're telling us that f prime has horizontal tangents at x equals -1. So has a slope of 0 there at x equals 1 and at x equals 3. And we can see that from the graph. Then they're telling us some information about the areas underneath the curve, which we haven't done yet, so ignore that. We don't really need that for this. So part A, find all x coordinates at which f has a relative maximum and give a reason for your answer. So first thing we have to do is figure out what we're looking at on the f prime graph to determine the maximum or the relative maximum on the original graph. So on the derivative graph, remember that whatever is above the x-axis is where the original is increasing, and wherever is below the x-axis on the derivative graph is where the original is decreasing. Okay, so when we have a relative maximum, just, any relative maximum, right? If I draw something like this, what happens at a maximum is that the graph goes from increasing to decreasing. So when I look at my derivative graph, I can see that increasing to decreasing of the original happens right here. It goes from increasing and then it goes to decreasing. So on my derivative graph, I'm looking to see where my graph is going from above the x-axis to below the x-axis. So right here at -2, that's going to be where I have a relative maximum because it's going from above the x-axis to below the x-axis. So I just pre-wrote these answers out because you don't want to watch me write out all these words. So f has a relative max at x equals -2 because f prime changes from positive to negative at x equals -2. So that's our giving a reason for our answer. When we're writing our answers, we want to write little sentences that kind of explain how we know the answer is what it is. We also want to make sure that we're being very specific as we can be. So we don't want to say something like, there's a relative max at x equals -2 because it changes from positive to negative. Okay, never use the word it. Okay, you always want to make sure that you're stating exactly what you're talking about. So this is because f prime is changing from positive to negative. Okay, for part B, I'm going to just get rid of this little dot so we're not confused. Part B, on what open intervals contained in -3 to 4 is the graph of f both concave down and decreasing? Okay, so already I know where the original graph would be decreasing because here's my derivative. It's decreasing when the derivative is below the x-axis. So all here is where it's decreasing. But I also want to figure out where is f going to be concave down. When we're talking about concavity, we're dealing with the second derivative. So if I'm looking at the derivative graph, the second derivative would be the derivative of the derivative, meaning that I'm looking at the slope of the derivative. So if it's concave down, that means the slope has to be negative. So when I look at what's underneath the x-axis, I'm looking to see where the slope is negative. Well, the slope, change to a highlighter. The slope is going to be negative here and here. So in the intervals where it's both concave down, so concave down is right where I have my yellow, it would technically be concave down all the way from up here as well. I'll put this in a different color. So this included with the other piece would be concave down. However, because we're looking to see where it's concave down and decreasing, it is not decreasing up here. So we're only dealing with -2 to -1 and 1 to 3. So again, here's my written out piece here. So -2 to -1 and 1 to 3. And my explanation is because f prime is decreasing and negative at these points. So if f prime is decreasing, that means that it's concave down, because if f prime is decreasing, that means that the slope is negative. And then when f prime is negative at those points, when f prime is negative, that's when the original function is decreasing. Okay, so let's look at part C. So I'm going to just get rid of these. Find the x coordinates of all points of inflection for the graph of f. Give a reason for your answer. So when we see points of inflection, that's dealing with the second derivative again. So we want to see where is the second derivative changing sign. Since I'm looking at the first derivative, in order to figure out the second derivative, I need to look at the slope. So what I'm looking for is where is the slope of this graph changing? So the slope of this graph is changing here, right? The slope was all negative until we get to this point. Then the slope becomes positive. Then at this point, the slope becomes negative. And then at this point, the slope becomes positive. So on our derivative graph, wherever we have local mins and maxes, that's where we're going to have inflection points. So again, where's my, oops. Okay, so the point of inflection, when you're describing it, when you're giving your reason for your answer, you'll see I broke this into two different pieces because of the explanations were a little bit different. So I have a point of inflection at x equals -1, so that's this one, and at x equals 3. And notice that I lumped these two together because they both were relative minimums on my derivative graph. So I'm saying that there are points of inflection because f prime changes from decreasing to increasing. Okay, meaning that the slope changes from negative to positive. And then I have another point of inflection at x equals 1. Okay, and that's because f prime changes from increasing to decreasing. Okay, so I split them up because their reasonings were flipped pretty much. Okay, but I want to make sure that I'm explaining why it is a point of inflection. Okay, so let's look at another problem. Okay, so this figure over here is the graph of f prime. So again, we're looking at the derivative graph. And then they tell us that it has horizontal tangent lines, so similar to the other question, and it tells us there's a vertical tangent line at x equals 3. So we can see all of this from the graph. The horizontal tangent lines are where we have derivatives that are equal to 0, and then we have the vertical tangent line where the derivative does not exist. So for part A, find all values of x for -7 to 7 at which f attains a relative minimum. Justify your answer. So again, similar to the previous question, relative minimum, I'm going to look at the graph itself. And again, like we showed in the other problem, if it's above the x-axis, I'm just going to call it f. F is increasing. If it's below the x-axis, f is decreasing, right? The original function. So I have a minimum. I'm going to just draw this over here, right? A minimum happens when I go from decreasing to increasing. So when I go from below the x-axis to above the x-axis, like right here at -1, that is going to indicate that I have a relative minimum on the original graph. Okay, and so even though here I'm crossing the x-axis, but it's going from increasing to decreasing, so that would not be the right one. And then here at 5, it was decreasing, or sorry, it was increasing, but it never changed. It kept increasing even though it touched the x-axis. So that would be neither a max nor a min. Oops, too much. So x is equal to -1. That's where we have a relative minimum because f prime of x changes from negative to positive at x equals -1. Okay, again, don't use it or any inconspicuous word. Part B, find all values of x for -7 to 7 at which f attains a relative maximum. So same question pretty much, but a relative maximum, oops, like the other problem that we had, will go from increasing to decreasing. So that's going to happen at -5. All right, so x equals -5 because f prime of x changes from positive to negative. Very similar. Now part C says find all values of x for -7 to 7 at which f double prime of x is less than 0. So this is asking us for where is the second derivative going to be negative. Okay, so again, when we're dealing with a second derivative, we are dealing with the derivative of the derivative. So I'm looking to see where is the derivative of this, so where is the slope of my graph going to be negative. So I'm looking at my graph, and I can see that the slope is negative. Oops, there. And then I have a negative slope. Now pay attention here because it's going technically negative slope all the way, but at 3, we have a vertical tangent line. So we can't include 3 because there's, oops, pretend that's a vertical line there, right? The slope is not going to be negative at that point. The slope is not going to exist. So we can say that, oops. Okay, so from -7 to -3, from 2 to 3, and from 3 to 5, okay, that's where the second derivative is going to be less than 0 because the second derivative exists and the first derivative, f prime of x, is decreasing. So f prime of x is decreasing. That indicates the negative slope. And it's important to note that f double prime exists because at 3, right, the derivative won't exist because it's undefined. So we're not including 3 technically. We're like jumping over 3 since it's not including it. But we want to make note that that is what's happening here. Okay, then part D, at what value of x does f attain its absolute maximum? Now, this one's a little bit trickier because we don't have a function. Now, usually, when we're trying to find the absolute maximum or minimum, we find our critical points, we use our endpoints, and we make that f and f of x chart, and we plug in the values of our critical points and endpoints into our original graph or original function, and we look to see what's the highest and lowest number. But here, we don't have a function to plug things into. So what we need to do is just think about what's happening here. So based off of the other parts of this question that I already answered, I'm actually going to get rid of this for 1 second. I know that I can see from my graph that I have critical points at -5, at -1, and at 5. Right? That is where it's crossing the x-axis. So those are my critical points. However, I already know that -1 is a local minimum because it's going from decreasing to increasing. So this can't be an absolute maximum. So I'm going to ignore that piece. 5 does not change signs. It doesn't go from negative to positive or positive to negative. So this is neither a max nor min. So I can't use 5. So if I were to make my normal chart with my critical points, I could include them, but like there's no point because they're not local maxes. So -5 is a local max. So what I'm going to focus on here are the endpoints. So I'm focusing on -7, I'm focusing on -5, and I'm focusing on +7. Now what we want to do is see what's happening with this graph. Now a -7 is where I'm starting out. As I go from -7 to -5, my graph, my derivative graph that I'm looking at, is still above the x-axis. So that means my original function is increasing. So if we try to just, I don't know, make a little rough sketch here. From -7 to 5, the original function is going to be increasing. So even though it looks like on this graph that it's going down, right, it's still above the x-axis. So my original graph would be increasing. So I'm just going to put this as -7 here, and like this is -5. So based off of what's happening here, that the original function is increasing from -7 to -5, I know that -7 can't be higher than -5, right? -5 is going f of -5 is going to be larger than f of -7. So right away, I'm going to get rid of -7. So I cut that out. So now, as of now, my absolute maximum seems to be -5, but I do have to check the other endpoint. So from -5 to -1, I do decrease. So I'm going to go boop, decreasing. So that causes that maximum. But then when I get to -1, we'll call that -1, it's increasing, but it's increasing all the way to 7. So increasing, I ran out of space. But 7 is going to be pretty far right because the distance between -5 and -1, which is where it was decreasing, is smaller than the distance from -1 to 7, where it's increasing. So somewhere, whatever up here, is where I'm going to have +7. So f of 7 will actually be greater than f of -5, making 7 our absolute maximum. So hopefully I wrote it out a little bit easier to understand. Oops, down here. Let's get rid of that. Okay. So what I did here is I said f prime of x is equal to 0. So I'm finding my critical points. Like I said, my critical points are at -5, -1, and 5. And I know I have a local max at -5. So my possible absolute maxes are going to be -7, -5, and 7. Right? My endpoints and my maximum critical point. At x equals 7, that should say as f equals -7, sorry. At x equals -7, f is increasing until x equals -5, right? That's what I said here. So f of -7 is going to be less than f of -5. F then decreases from -5 to -1, and then increases over a longer interval from -1 to 7. Therefore, f of 7 has to be greater than f of 5, making x equals 7 the absolute maximum. Okay, so it's a little bit trickier because you're not making your chart, but you have to be able to understand what's happening with the derivative graph that's affecting the original graph. Okay. All right, so we're going to look at one more. Okay, now this one's written a little bit differently. So here they're telling us that g is the function given by this. Now we are going to deal with this type of function a little bit later on. You're going to see this is an integral, and we haven't done them yet. Okay, but if you see a question like this before you even know how to do it, the main thing here is that noticing that the graph we're given is the graph of f. When you have this weird little symbol, which again we'll talk about at another point, this graph is really going to correspond with the derivative of this. So if g of x is this weird thing of f is really the same thing. I'm just going to put equals g prime of x. Okay, so this is the graph of the derivative of this thing. Okay, so don't worry about this thing right now. Just if you see this thing, just know that the graph you're seeing is really the derivative of the whatever you see on the left, the left side of the equal sign. All right, so the left side of the equal sign, take the derivative of that, and that's what the graph is. Oof, bad circling. All right, so just something to be aware of. So I wanted to show you that so that if you ever see that before we get to it, don't panic. The graph is just the derivative of this. So same thing that we've been dealing with. So find g prime of -1 and g double prime of -1. So if this is the graph of f, it is just the graph of g prime. This is the same exact thing. So g prime of -1, I'm going to use my graph. Because this is the graph of g prime of -1 is the value I see when x is -1, which is 0. And g double prime of -1, well, that is the derivative of the derivative, so that means the slope. So I'm looking for the slope at -1. So we're just going to count the slope. We go up 3 and over 1, so our slope here would be 3. Okay, so g prime of -1 is 0, g double prime of -1 is 3. Part B, for what values of x in the open interval -2 to 2 is g increasing. So again, we have the graph of g prime. We want to see when is g increasing. So if I'm looking at the derivative, my original function will be increasing where the derivative is positive. So I'm just going to slide this down here. Oops. So -1 to 1, right? Because that is the place that has a positive derivative, right? G prime of x, which is equal to f of x, is positive, right? We said f is the same thing as g prime in this case, so it's positive. And then for part C, for what values of x in the open interval -2 to 2 is the graph of g concave down. So we're looking at the derivative graph. So if I want to deal with concavity, that's the second derivative. So I'm going to look to see where the derivative of the derivative is going to be negative because it's concave down. So I can see that it is negative slope. Oops, there. So we have from 0 to 2 because g prime of x, which is f, the same thing as f of x, is decreasing, right? The slope of that is negative.